you like playing with a ball? Everyone likes playing with a ball. Or at least played in childhood. It's a part of our lives, you know. Let us pretend like being in a huge arena watching an important game. It can be a football game or a basketball game or a volleyball game. It really doesn't matter what it is. And think about the game is approaching the climax. Very critical moments. Something definitive is about to happen. And your cell phone rings. As always. It always rings at the most inappropriate time. While you are getting rid of the cell phone issue or taking a selfie, crowd groans and you fell into a big curiosity. Where is the ball? What happened? Where is it? This moment, you step into the realm of kinematics. Because the ball is a moving object and the study of motion is kinematics. Where is it? How did it go there? Did something happen in the process? These are the questions a physics-free mind can ask. But we can do better than that. When you ask where is it, you actually wonder what its position is, how much it displaced, what is its displacement, what is the distance covered. When you ask how did it go there, you wonder actually which way did it move, what was its direction, was it quick or slow, how was it fast, what was its speed, what was its velocity, did it get faster while moving, did it slow down, did it change the direction, what was its acceleration. These questions lead us to define the terminology of kinematics. We need to know what are these. Let's start by talking about position, displacement and distance. Here is lovely neighborhood. There is a shop here. This is your house and your school. Assume that there are 3 units between your house and shop and 4 units between your house and your school. The house is our initial point and we denoted it by U. And today you need to go to school as usual. When you reach the school, you positioned yourselves at the point of 4 units. Position is a point in space which does not include enough information for many cases, so we can provide better understanding using a vector which can be drawn from the initial point U to the final point denoted by V. By doing so, we defined our position in space as 4 units to the east. The magnitude of this vector is 4 units and direction of it is to the east. And we traveled 4 units so far. After the school, we need to go to the shop to buy some stuff, let's say for a physics project. We traveled in opposite direction, past the house and reached to the shop. Total distance we covered is house to school 4 units, school to house 4 units and house to shop 3 units. The distance we traveled became 11 units so far. The length of path traveled is distance. Our initial position is the house U and our final position is the shop V. Total displacement is house to school 4, school to house 4, house to shop 3. It is in total minus 3 units or 3 units to the west. So, displacement is the overall change in position, the vector connecting 2 points along the shortest path. When we return home, the total distance we covered is house to school 4, school to house 4, house to shop 3, shop to house 3. It is in total 14 units. The displacement is, let us pick the plus sign for east, so 4 units to the east, 4 units to the west, 3 units to the west, and 3 units to the east. The displacement is 0. This is one-dimensional example. Let's consider another beautiful neighborhood. Seeing these all in 2 dimensions might be very useful too. In this neighborhood, to go to school, you need to travel 4 units to the north and then 3 units to the east. So the distance denoted by S is A plus B, that is 4 plus 3, which is equal to 7 units. In order to find the displacement, we need to define 2 quantities: the magnitude of the vector and second, the direction of the same vector. We need to use the Pythagorean theorem to define the magnitude, which is S squared is equal to A squared plus B squared. The absolute values of vectors are their magnitudes basically. Take the root of both sides, put the values in, and 16 plus 9 root of 25, this is 5 units. Okay, what does finding direction mean? It means defining the declination angle. Let us name that angle as theta and alpha. If we can find theta, we can find alpha. So we need to use the value of the tangent theta, which is B over A. So arctangent B over A gives us the angle theta. Arctangent 3 over 4 is 36.87 degrees. Alpha is equal to 53.13 degrees. So the displacement vector is 5 units, 53.13 degrees. This ball moves from A to B by following a circular path with the radius 10 over pi. Let's find the distance and the displacement. We know that the circumference of a circle is 2 pi r. The ball travels half of the circumference, so the distance S is equal to pi r. R given as 10 over pi, so the distance S is equal to 10 meters. We know that displacement is a vector, so the magnitude is equal to 2r. That is 2 times 10 over pi, which is equal to 20 over pi. And the displacement vector is 20 over pi to the east. If you want to calculate exact value, you can use your calculator. You will find S is 6.36 to the east. We now can see the vectors, position vector and displacement vector in action. Now, take a look at that neighborhood. The distance between house and school is S. See what happens when you're late to school. Did you notice what happened? Watch it again. Watch them together for better comparison. What changed? Same distance, same people, but in the first case it takes 2 units of time, but in the second case, when you're late, it takes 1 unit of time. What changed? You are faster in the second case, yes. But what does being faster mean? It means you are taking more path per unit of time. You are taking more meters per second. Meters per second. This concept must be investigated in two subsidiary concepts: speed and velocity. The speed tells us how much meters an object passes in how much seconds, regardless of direction. Speed is a scalar quantity. Assume that the speed of the students is constant all along the way. That means every moment on the way they take same amount of path. This is called uniform motion. Let's observe that motion again. If you take A to B 100 meters in 20 seconds, your speed becomes 5 meters per second. Similarly, if you take B to A 100 meters in 20 seconds, your speed is still 5 meters per second. We need two quantities to define the speed: the difference between final and initial positions over the time interval you spent during this motion. This is the time between the moment when you are in your final position and the moment when you were in your initial position. Delta is used to express the difference. So, speed is delta S over delta T. As we choose the beginning point of the motion as 0, this calculation actually includes minus 0 component. On the other hand, we have velocity. The velocity tells us how much meters an object passes in how much seconds in which direction. Velocity is a vector quantity. Let's observe the same motion A to B by considering the direction. Same 100 meters in same 20 seconds to the east. Direction is important. Now, see the motion B to A. In this case, velocity becomes 5 meters per second to the west. These are not the same. We are interested in the beginning and the ending of the motion, not in between. So, these values are called as average values. Now, let us consider another scenario. While you are going to school, you thought that you forget something back at home. You try to be sure, meanwhile, you slow down. Then you recognize that you are getting late for school and start to run. While me drawing coordinates, you can observe that motion again. Let's investigate that motion a little bit in details. Let's mark the velocities. In this case, your motion is not uniform. It's changing in time. Your velocity at an instant is called instantaneous velocity. The instantaneous velocity of an object is the velocity of an object at a particular moment in time. It is the velocity of an object at an instant. The information of direction included. The instantaneous speed of an object is the speed of an object at a particular moment in time. It is the speed of an object at an instant. The information of direction is not included. Even though the instantaneous values are different, average values are still having same values. We know that average speed is 5 meters per second and velocities are 6 meters per second to the east, 3 meters per second to the east and 10 meters per second to the east respectively. Let's assume that 5 seconds passed for the tennis ball reached to the final position. We know that the distance traveled is 10 meters and the displacement is 20 over pi. So average speed is total distance over total time. So 10 meters over 5 seconds is equal to 2 meters per second. In the other hand, average velocity is displacement over total time. So 20 over pi over 5 is equal to 4 over pi meters per second to the east. Change in velocity is a thing that we need to pay attention closely. Now, be patient and observe these two motions. What is the difference between these two motions? Yes, you got it. The second one is getting faster and faster. Its velocity increased per unit of time. That means it is gaining velocity per unit of time. Meters per second per second. We can rewrite that as meters per second square. This is the unit we are going to use for acceleration. Now, let us zoom in and put the velocity values into a graph. We now can clearly see the change in velocity, which is called acceleration. Acceleration is the change rate of velocity. If we talk about velocity changing over a specified interval of time, that means we talk about average acceleration. It is actually easy to say that this is the slope of this graph. If this interval of time is tremendously, enormously small, which means that time is an instant, it is called instantaneous acceleration. Acceleration is a vector quantity, just like velocity. If we know how velocity change, we know how acceleration change. If the magnitude of velocity vector or direction of the velocity vector or both change, we can talk about acceleration. This is change in magnitude. This is change in direction. This is change in both magnitude and direction. The most common case we face with the acceleration in daily life is being in a vehicle like car. When the driver steps on the gas pedal, the thing what pushes you back is acceleration. Now, compare these two vehicles in terms of acceleration capabilities. Okay, we now have our result. 100 kilometers per hour in 10.12 seconds. And the second one is 100 kilometers per hour in 6.79 seconds. The first thing we need to do is convert these kilometers per hours into meters per seconds. Let's do that. 1 kilometer is 1000 meters and 1 hour is 60 into 60 seconds. So 100,000 meters over 3600 seconds is equal to 27.78 meters per second. This is our delta V. We know what delta is standing for. So 27.78 meters per second over 10.12 seconds is equal to 2.74 meters per second square. Similarly, the second value is 4.09 meters per second square. Don't forget that these are vector values, so the information of direction should be included. Now, let's repeat what we have just learned. In this section, the concept of position, distance, displacement, speed, velocity, and acceleration introduced to you. Position is a point in space. It is a scalar, and its unit is meters. Distance is the length of path traveled. It is also a scalar, and it has the same unit, which is meters. Displacement is the overall change in position. Displacement is a vector. The unit is meters, but direction must be included. The speed tells us how much meters an object passes in how much seconds, regardless of direction. As we don't care about the direction, this is a scalar, and the unit is meters per second. Velocity tells us how much meters an object passes in how much seconds in which direction. In this case, the information of direction must be included. The unit is meters per second with the direction, because this is a vector. Acceleration is the change rate of velocity, which is also a vector. The information of direction also must be included. The unit is meters per second square. We need to handle the concepts of speed, velocity, and acceleration in two types. The first one is average, and the second one is instantaneous. Average speed is the speed of an object at and over a specified interval of time. Average velocity is the velocity of an object over a specified interval of time, likewise the average speed. Average acceleration is similar. It is the change rate of velocity over a specified interval of time. Instantaneous speed is the speed of an object in an instant, and the instantaneous velocity is the velocity of an object in an instant, just likewise the speed. But in this case, this is also a vector, and the direction of the velocity must be included. Instantaneous acceleration, similarly, is the change rate of velocity in an instant. It's now time to test yourselves.